So today's lesson is to help you with lines and equation practices, pages 1 through 4. And in these activities, the idea is we begin with an equation. We're given 6 equations. And the idea is we want to make a table for each equation and then use the table to make a graph for each equation. So I'm just going to do the first one. And in this one, the equation is y is equal to x. So whatever x is, y is equal to it. It's the same value. So when x is negative 2, that means y is negative 2. When x is negative 1, that means y is also negative 1. When x is 0, so they're all actually equal. They're equal to each other. 1 and 1, 2 and 2, 3 and 3, because x and y are equal in value. Now what we've just done is generated a table of values for the line that represents y equals x, and these are coordinates or pairs that go with it, and the x value is first. So I'm going to actually go down to the graph down here and use these numbers in the graph, and the first number on the chart is negative 2, negative 2, where x is negative 2 and y is negative 2, which is right there, right in that spot. So negative 2, negative 2. X is negative 2. This is the x line. This is the y line. If I go x is negative 2 down to y is negative 2, that's that point. And then if I look at the next one, negative 1, where x is negative 1, y is negative 1, and that's the next point. And then 0, 0. And then when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. And oops, 3 up there. And so now I have all these points that represent the line for y is equal to x. And I can put my ruler down and connect those dots. And they can extend beyond the dots that I have because the line continues in either direction forever. So I'll just take it a ways out here. And then now that represents the line y equals x. And so I'm going to actually put that at the end here so I know that that's a representation of that line. And then if I go to the next equation, y is equal to x plus 1. So whatever the value of x is, if x is negative 2 and I add 1 to it, that becomes negative 1 because a positive 1 and a negative 2 added together make negative 1. So that's the value of y when x is negative 2. When x is negative 1 plus 1 is 0. When x is 0, 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. Now once again I've generated a set of values for x plus 1, this equation. So y is just our answer when we change the value of x to these different values. And it creates a line, and we can graph these points below. So negative 2, negative 1. So I go over to negative 2 and down to negative 1. So there's a point. And then negative 1, 0. Negative 1, 0 stays right on the line because we don't go down or up, it's 0. And then 0, 1, 1, 2, 2, 3, and 3, x is 3, y is 4. So there's the next set of points. And you see now we have a bunch of points that if we connect them together will make a straight line. So that's what I'm going to do. And I can extend it further in either direction, but I'm going to stop there. And this is the line for y equals x plus 1. And there's more values going either direction on forever. And I can continue to do this. I'm actually going to jump over to this one here. This is y is x plus 5. So the idea again is I have a value for x, negative 2, plus 5. So negative 2 and a 5 make 3. A negative 1 and a 5 make 4. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. And 3 plus 5 is 8. And so now I have a set of values for y when x is changing. That's what a variable is. The value of x changes. And that means the value of y changes as well. And it creates a line. So I'm going to put these on the chart. So negative 2, 3, negative 2, and then up 3, positive 3. So that's your y value, 3, and your x value is negative 2. These are all just coordinates. And then negative 1, 4, negative 1, and then up 4. And then 0, 5. So these are just coordinates, 0, 5. 1, 6, 1, 6. X is always first. That's the value of x. And then 2, 7. So over 2, up 7, over 3, up 8. You can see one of the ways to check yourself on this is if a dot is not in a line, since these are all linear equations, then something went wrong somewhere along the way. Again, these lines extend in either direction. As far as I want to go, I could keep going with this one further down if I want to, because these are all will be points on this line. If we extended our table or our graph, everything just continues on. And this is y equals x plus 5. And so that's all that this activity requires. There's a number of variations. Sometimes we have multiple numbers or multipliers of x, and so finding these values could be a challenge. But one of the ways to take care of that is to use a calculator. And so if I were using my calculator and I push the y equals button and I put in one of my equations, x plus 5, the x is next to the 7 on this calculator. On some it's further up, but x plus 5, and then I show the table for it. There are those values that I just had. So I have the 3, the 4, the 5, the 6, the 7, the 8. So those are my original numbers that I found. So I could put any equation in there just to check. I'm doing x minus 3 since we have that on this table, and I could find it that way. And so there's my values for x minus 3. We have negative 5, negative 4, negative 3, negative 2, negative 1, and 0. And then I can graph those points and see where that line falls. So that's all we're doing in this particular activity, is trying to fill in the tables and then use the points on the table to complete the lines, to show where those lines are for each of those equations. And that's it for that activity.